Hello everyone, welcome to Practical GCP. So today I'll spend some time to talk about the automated data profiling and quality scan features added to Dataplex quite recently. So data profiling and data quality scan combined can offer you the ability to see what are the potential issues you've got with your data, and then to periodically scan them by setting a set of rules so that you can keep good track of what is actually happening with your data quality. So I'll start by explaining the difference between data profiling and data quality scan and run into some of the key features of what the automated profiling and data quality scan can do for you. Also some of the interesting features around the hinted quality rules, right? So based on the profiling results, and how you can actually use YAML and the CLI of the G-Cloud command to actually manage those creation of the data quality scans. I also explain some of the other options that you can use to create the quality scans, and as well as some sensitive data considerations when you actually do the scanning. So what is the difference between data profiling and data quality scan? So data profiling is actually a process of analyzing and summarizing the characteristics and properties of a dataset. So it aims to gain a better understanding of the data's content, structure, and quality. So in a nutshell, it's basically some kind of analysis and summarization of the potential issues, right, you might be getting to actually lead to yourself or the organizations making better decisions on how to actually set the rules on your data quality scan. And the data quality scan itself is a systematic examination of data to access its overall quality. So that could be including accuracy, completeness, consistency, compliance with the predefined data quality standard or the rules. So this is the thing we will be specifically setting with the data quality scan of Dataplex. So basically the quality scans goes way beyond just the profiling, and it will actually evaluating the data against specific quality criteria or rules, and very typically on a, let's say, daily basis or regularly. So in terms of the auto profiling, so this is what it looks like, right? So when you run the auto profiling, you get a result. So this is a BigQuery table. I'll show you the actual one in a second. But basically, you get some look like this, right? So this gives you a number of very important metrics for each column in that table, so that you can understand exactly what is actually happening with your data. So actually, instead of showing you on this screen, let's just jump to the actual data set and the table, so it's easier to see the entire thing. So the table I'm using, this one, is the London bikes cycle hierarchy. This is the data set I've actually copied from the public data set. So you can see you've got a bunch of columns with the IDs and durations, start and end date, but there's some very interesting ones such as the start station IDs, right? So you can't really use this data if you don't know, which station IDs kind of got started. So this could, if this quality is not great on this column, it could cause data quality issues for us to analyze or build our systems. So the data profiling, if you look at the ones already done in here as a scan, so you can see here, it has actually given us a breakdown of all of the columns, and specifically, the type of the data and uniqueness and percentage of null. So these are the two very important metrics that to identify what is the potential issues of those columns. So if you look at the bike model, right, there's actually 67.93% are actually nulls. So the rest, so you basically only talk about 23% that is actually you've got data in there. And this one, you can see the bike ID, everything is actually has an actual value. And then this one, you've got the unique percentages. It basically tells you how unique kind of the data is. On the right hand side, you've got some other very interesting and useful metrics: the average, the standard deviation, and on the bottom the bottom right, this bit, you've got a minimum maximum, right? This can be very useful to understand the kind of distribution of your data. So it uses the minimum and maximum plus the quartile, the 3 quartiles. You've got the lower, which is 25%. You've got the 50-50, which is the median, and then you've got the 75%, which is the upper quartile. So this actually gives you the distribution. You can see that's like you've got 1 here, and then some of these ranges here, this jumps to 90. So you're kind of like thinking, hang on a second, why you've got this number here, right? So it gives you some idea of looking at the distribution of the data. Yeah, so if you look at some of these other ones here, so right, this one is actually quite useless in my opinion, because this is actually a Unix timestamp in this particular case. So it still did analysis to you, but you know, when you run your data scans, I think it's really important to think about this is the profiling scans, right? To what kind of tables do you use it on, right? So if you use it on Unix timestamp, you can see here that this is not actually very useful in terms of easily seeing if there's an issue or not. Some of the other ones is actually really useful. If you look at, I think one of the columns I mentioned before, like the start station ID, right? So this one is something we really kind of need to use in order to make sense of this data, because otherwise you don't know for a bike ride where it actually started, right? So this, you can see the percentage of null is actually 0.28%. So it's not actually 100%. So I'll show you later on in the data quality checks. This is actually very useful to set as a rule to make sure this one, you probably always want to have, let's say, 99 or 100% of this ID in this table must not be null, right? If it is, then it's going to fail the data quality check. So you can actually see and alert you based on those metrics. Some of the other interesting ones you can see, this one I saw yesterday, you got the minimum and maximum, but you see the quartiles actually only goes up to 600, and then suddenly you've got something like, what's this? This is like a 3 million, right? So you know, like, hang on a second, what is wrong with the data? Actually, when I look at this one, it looks like the ID systems for the stations has actually changed from about 2000. So this actually changed completely. They used a different ID system. So these are the things that are important to know. So when you get this these kind of metrics in the profiling, it can actually hint if there's any issues, and you can actually then you know, this can actually affect your decision most of the time. What do you want to focus on to check, such as the nulls, the uniqueness, and based on the quartiles that you might want to look at some of the specific checks in these areas. So that's pretty much the profiling. So it gives you something like this, and then you can actually then start using this to set the quality checks. So back to the slide. The next thing is basically the data quality scans. So data quality scan would give you something like this, right? So this is basically a breakdown of all of the columns with the rule you specify, and then the rule type, the evaluation, the dimension, and the parameters. So the dimension is basically a type of kind of rule you set, and then within those dimensions you can see completeness, and then that's basically the null check. The validity, that in this case you've actually given a row condition check uses SQL, right? And then the few other ones is actually the same. And this one in here with rental ID is kind of uniqueness, which is you can check, you know, how unique you want it to be. And then you have a threshold here you can set it to, right? So you can say 90%, 100%, or 99%. So these are the variations you can set. So let's have a look at this one as well in the data quality checks. So this is the first one I've done. So look, you can see I've created the rules and then I set it. But in here, you can see the interesting thing is, remember that start station ID I mentioned, right? So actually, instead of letting this just through with 99%, I've actually changed this to 100%. So in this particular case, you can see this completely has failed, right? And this is very useful. When you click on it, right? When you click on it, it says one dimension and it has failed the rules. And you see this one start station failed is is failed because of the null check, right? It's the completeness dimension row check. And what's very interesting is this. It actually gives you this query, right? This query to get failed records is actually the one you can just click on, right? And then you go to BigQuery, let's say open a new tab or something, and you can actually run it. And this will basically give you all of the records that have the null column. You can see here you have the start station ID as nulls. So this is very, very useful for you to identify after you've got a failed check to see, hang on a second, exactly what has failed it. So all of that information is made available to you in the same place, right? So that's the data quality check. Right, one thing I want to talk about briefly is why these are called automated checks, right? You might see, okay, you still have to set everything. I think in the past, you had to run your own jobs, right? Deploy your own environments to run those things. So, but what Google has done is they have created a product for you to basically, all you need to do is to specify, if you look at what I've done here, is to specify, if you look at profile, right? All you have to do is to create a scan with a bunch of things, right? You specify the table, and then you specify, do you want to do an incremental scan or entire scan? And then you can do the filter of rows or columns, and then you can choose your sampling size, and that's it, right? Then you can basically either do it on-demand profiling or repeat on a schedule, but you don't have to actually provision any clusters or run it. So this is where the automation comes in. So it's exactly the same with the data quality. So here, when you create the data quality scans, again, you specify the ID, you specify the table, and then you specify the sampling ratio, and then, yeah, and it's the same thing. The data quality rules in the next page, I'll come back to that. But this is where the automation comes in. And one of the very interesting things I found in here, I think Google is going to, no doubt, because all of these capabilities of kind of AI inferred kind of decision making to give you better recommendations, is this profiling hinted quality rules. So this, let me show you what I mean by that, right? So if we go back to the profiling, right? So we have actually done a profiling, and it tells you these are the issues, potential issue we get. This is data quality checks, right? These are the things you need to do the data quality checks on. And then you go to the data quality check. What you could do is, let's say I'm going to grab the table name, right? So my table name is, in details, is this, right? And then what I'm going to do is I can specify ID, put the table in there. I'm going to say do the entire data, and then we'll do, let's say, 20% of sampling. But next, you see this in here, this is where it gets really interesting. You can add rules, and one of the options is profile-based recommendations. If you get into this one, you see, I have not actually done anything yet. And then this has already given me a bunch of suggestions on what kind of data quality check I should do, right? So it's pre-filled all of these things. So, and then if you look at the bike model, and then here is giving you the length of bike model is greater than or equals to 1, 0, and the length or less than equals to 10, right? So it gives you some checks. So this may or may not be correct, but it's actually a very good starting point. And at the end of the day, you don't really want to just do all of these things from the UI, right? But what the UI can give you is, some rules, because this is the whole point of profiling. If you've done the profiling, if you actually design it well, you could get very useful results in here, and then save you a lot of time on, rather than setting the data quality rules from scratch, and it actually can give you, this is a good place to start. So however, there's a problem, right? So, after you've done that, you can run the scans, but there's no easy way to put this in version control, right? Or let's say if you what's good in here is you can actually, if you select it, and then you can actually, you can actually change these things. You can actually change like what the query you want to run, and you can, use a different tab to try them out. But there's no easy way to export this thing, right? Because one thing you can do, as I mentioned in here, is you can actually use something like YAML, like this kind of format, right? you can use this kind of format to define the rules, and then for every single column, right, what dimension you wanted to check it with, and then what the expectation you want to set, and then this can be loaded via the G-Cloud CLI to actually apply this to create a scan, right? So, but there's no easy way to actually get this information out. Let's say if you prefer to use the UI and it gives you a lot of information, but you can't actually get this out of it. So what I have done, I thought it might be useful. You can see the second one here is actually called imported. So what I've done is, if you look at this, which I will share with you in the source code. Actually, I did share with you. If you click on this light, this light bubble, and that will actually jump to this repository. So what I've actually done here is, I've not actually validated fully yet, but this is just a small Python script. What it does is you can specify a project location and a data scan ID, right? So once you've got that, what this would do is to go through all of the different type of expectations, because some of this is a bit more complex than the others, and it will set the it will unpack the if let's say if you have a SQL in there and you have a regex in there, you'll basically unpack this and then output a YAML for you. So this one is the one I've got, that what I've been running. If I go into the main Py, and then you can see I've in the environment variable I've pointed to my one. So this is the data quality check London bikes, right? So then this is in my sandbox project, and then this is the region. And then when I run this, you can see it's actually extracted all of the information from from this user interface that we've seen, like this one, right? This is the one it's pointed to. It's actually extracted everything we've got here into the YAML, into a YAML file. And then what we can do is, if you go back to the instruction in the README, you can go into this data quality scan G-Cloud command, right? So what you can do is you can then run the data scan, create data quality with the data scan, the location, and the file. This one is the one you can basically put what just got generated in there in the YAML. And then basically point to the BigQuery table or your lake to basically create the data quality checks. So this is actually quite handy because this generates a lot of the stuff for you, right? So once you have the YAML, you actually have a really good starting point to set a lot of this stuff from a template, which would save you a lot of time, right? Based on the data profiling results. So this is something I found quite useful. So the code I've put in there, so you can use it if you want to, but just double check this because I've written it only in an hour or something. So yeah, so it might not cover all of the cases that you need, but just double check. But it is a concept I think is quite useful because of the UI capability of the recommendations of the rules of the data quality checking to set based on the profiling results. Okay. There are also a few other options that you can create scans. One of them is via Terraform. I think I have a link in there as well. Yeah. So the Terraform one is also very comprehensive. You can see it's very, very similar to the YAML one. You have the basic profile one you can set, and then where you send the full profiling, you can then specify the data profiling specifications, right? And then below there you have the quality checks with the basic one, and then the one similar to what we've just done with the rules. The issue I found with this is, although in the documentation it has mentioned we can use the YAML with Terraform, but I couldn't find a way to make it work. So I hope this would be possible, because then I can just feed the YAML into Terraform somehow, and then keep all of this data quality checks managed in Terraform instead of using G-Cloud. Then that will be a lot easier to track the states. But if it's not, then the G-Cloud would be the other option that you can set all of these checks. Also, you can actually use the Airflow or just the pure Python library option. So what this is useful for is that imagine you've got a data ingestion pipeline, right? So at the end of that day, you've incrementally loaded a bunch of data into your table for that partition. That as part of that that Airflow DAG, at the end you can actually add a step like this. You can say I want to add the specification and then to validate this stuff, and you can actually just trigger it. So the first time you can create it, but the second time you can just trigger it, and then what that means is you get data quality checks every day after ingestion is run for the data lake tables. So that's another use case I think you can consider. Okay, so these are the two options with either Terraform or Airflow Python. But the one I prefer the most would be using the YAML, because that's actually quite easy to manage. And then if it's supported by all of these different things, and that would be ideal. But I can't actually see how to use the YAML with the Python SDK nor Terraform. I can only see this work with gcloud command. But I think in my opinion, that's kind of the easiest way to represent your structure of the rules. Okay, so one thing you probably want to think about is this sensitive data considerations. You can see this is one of the data profiling was done on, I think this is the name of the bike station, right? So imagine this is probably your customer's first name, last name, date of birth, and all of this stuff. So in the data profiling, you have an option to exclude or only select certain columns that you want to run. So then if you have sensitive data like names, addresses, so you probably don't want to include those into the profiling results, because otherwise you could basically expose your PI information into the metadata, which is part of this this scans of the data profiling jobs. Okay, I think that's everything I have. I just want to quickly summarize. So with Dataplex, you can easily profile a large amount of tables because it's quite easy to set up. You don't need any infrastructure. And then this can give you a lot of potentially data quality issues that you want to do the data quality scans afterwards. So keep in mind, there is an option also to push all of these profiling or data quality scan results into a BigQuery table. So that with that option, you can actually run some reports to, let's say, if you want to look at certain area where there's lots of null columns, there's uniqueness problems, then you can actually curate that results into a much more understandable dashboard to actually keep you on track of all of the kind of potential data quality issues. Obviously, you can use the kind of recommendations to do the quality checks based on the profiling results, because those recommendations I found quite useful, because the profiling would give you some ideas of the ranges of data, the uniqueness of data, the nulls of the data. So then to use the recommendations, especially with the tool I've created, you would be able to maybe make some changes to productionize that and export those into YAML. Then you can actually redeploy and maintain those, not starting from scratch, which can save you a lot of time potentially. So the YAML-based data quality scan configuration is quite handy because it's quite descriptive. You can easily kind of check it. You can easily import it. So that's something I would I quite kind of as a preferred way. And then the integration with many data governance vendors. So I probably need to double check this, but based on my recent findings, a lot of this data governance tooling, such as Colibra, they potentially have these ways to harness data from the data profiling results and data quality scans from Dataplex. I need to double check that, but I think it's not just the Colibra. There's quite a few other tools, especially the Google Cloud provider, the Google Cloud partner ones. They have the ability to harness this information, which can actually visualize this a lot better with your kind of governance frameworks and tooling. There's also some downsides. So there's no easy way to export the recommendation of data quality checks via profiling. So this is the thing I wrote the tool for, but ideally, if this is just a button and say export this as YAML, right? And then it's a lot easier for you to then use that as a starting point to then make some changes and re-import as a much better data quality checks, and it also is easier to maintain that afterwards, right? With that, so it'll be nice to use the UI. If the recommendation is good, to make that as a starting point, then maybe just clicks a button from the UI to export it as YAML. Then it makes it a lot easier, to maintain it. It did mention in the documentation that you can use the YAML with Terraform, but again, I can't find how to do that. It would be good to see if there's a way to do that. Then it'll be much easier to actually manage the state with Terraform rather than just use a gcloud command. This is quite new. I somewhat find the documentation is just incomplete in a lot of places. So there's not a lot of good examples to show how to use this or how to deploy these. I think there are documentations that shows how to use, for example, the Terraform ways, the Airflow ways, but there's not really that much about showing how to manage this like cleanly. So I think it's just, especially I think it's the Python SDK, it's quite difficult to find things at this stage. So I'm hoping the documentation can be improved over time, but given this is quite new, so this is probably expected. But I think with the YAML-based way to describe the rules for the data quality checks, if that can be utilized more with more examples of how to do that and how to, maybe more features, how to interact with that with the UI, that would be a lot more powerful in my opinion. Okay, I think that's everything, and thank you very much. I'll see you next time.
Go out!